Good evening, everyone. Your instructor will be joining shortly. So then you are going to start in 5 to 6 minutes. Okay.
Okay, sir.
Hi guys, am I audible to you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am, you
Great.
are.
We'll just wait for 2-3 minutes more, then we'll just start with the presentation session today. Fine?
Okay, ma'am.
Yes,
Okay,
ma'am.
ma'am.
Yeah.
Excuse me, ma'am.
Yes.
Ma'am, I have a request.
Yeah.
Can I present the project first, ma'am? Because I have another class, so I'll have to attend that. If it's not a
Okay,
problem, I
fine.
can present first.
Okay, fine. You can.
Thank you, ma'am.
Hello, am I audible?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, fine. So Fida wants to present first. So after Fida, who wants to present?
Ma'am, me, Priyanshu.
Okay, Priyanshu.
Dikshant.
Okay. Just a minute, just a minute. After Fida, Priyanshu wants to present, right?
Yes, ma'am.
Okay. So after Priyanshu,
Ma'am, can I?
Dikshant.
sure, Aditi. So after Aditi, Dikshant, you can present. Next, after Dikshant,
Me, ma'am. Himanshu.
Himanshu. Okay, Himanshu. Yeah, after Himanshu,
Ma'am, Somna.
Okay, fine. Fine. So, Fida, you can just go ahead with the presentation, present your screen and start presenting.
Okay, ma'am. Thank you.
And try and complete it by 15 minutes, like within 15 minutes, fine?
Okay, ma'am. Is my screen visible?
Yeah, visible.
Okay. So good evening, everyone. Today I'll present a fraud detection mini project using a transactional dataset. So I'll start with EDA to understand the data and features, hypothesis testing, then walk through feature engineering, unsupervised analysis, and lastly the supervised models and their evaluation. So this project focuses on detecting fraudulent financial transactions. The dataset contains 5,000 records with 11 columns, including transaction details such as amount, transaction ID, transaction type, device type, and so on, and a target variable called fraud label. So, upon observing and knowing the data, out of 5,000 records, there are 4,851 which are genuine transactions, and only 149 are fraudulent among them, which means fraud make up about 3% of all transaction. So, this class imbalance is a key challenge in fraud detection. Coming to the business context, this ML approach helps financial institutions identify high risk transactions, and it provides business intelligence for fraud prevention, and also supports the design of ML powered fraud detection systems with accuracy. So, this is a fraud analytics and financial transaction subject. The data source I took here is the synthetic data set, which reflects the real world banking transactions. So these are the columns I have features and what the features tell. That is the description. Data pre-processing, as we know, data collection, then cleaning. If there are very few null values, we remove them, and if a lot of them, then we'll replace them with median for numerical and mode for categorical, removing duplicates, then standardizing categorical values, encoding and normalizing the numerical features, feature engineering, like uh, detecting outliers and treating them. The techniques, as so far we've covered whatever we've covered in the class since 4 weeks, everything this project includes, from EDA visualization, hypothesis testing, supervised learning models. Only a few, three of them have been included, and unsupervised learning and dimensionality reduction. Clustering have included. So importing the libraries is a code libraries for pre-processing in utilities like normalization, encoding, hyperparameter tuning, and evaluation matrices. These are for dimensionality reduction and clustering. Hypothesis testing, I've used a priori as association rule clustering, and for supervised models. So imported the dataset from GitHub.
Fida, I am unable to hear you.
Yes, yeah, ma'am, I'm speaking now. Creating a copy of the data set so as to retain the original data set as such. And this is the first. This is checking whether the features are copied correctly. You can see transaction ID, date, user ID, merchant ID, amount, transaction type. These are the features we have. We have latitude and longitude as well to detect the location. And there's a first 5 rows head dot head method, and last 5 rows, these are the random 5 rows we have. We can see the target variable here, that is the fraud label, either 0 or 1. 0 are the genuine transactions and 1 are the fraudulent transactions. So the data frame has 5000 rows and 11 columns. These are the column information, feature information. We can see there are many null values in merchant ID, amount, and device type here. We'll impute them later. So unique in each column, unique values in each column. Unique values in transaction type, we have online, a transfer. This is of point of sale, it is an ATM. In device type, mobile, desktop, tablet. So your total of null values, there are 100 values in these column: null, merchant ID, amount, and device type each. Visualizing the null values using missing no numbers, and this is a color map of the same. The yellow lines indicate the missing values. Finding the duplicates here, I've particularly taken the key indicator here because no two transaction can have same transaction IDs. So if there are any duplicates in the transaction ID, that means the whole row counts as uh, a false information. Thus, taking transaction ID as a key driver here, uh, we can visualize here there are two transactions of same transaction ID, which is not possible. So we'll keep the first transaction, we'll keep the first record and delete the duplicates here. So we're keeping the first occurrence and dropping the duplicates other than that. So these are the features we have. This is a numerical statistics, the count, like after removing the null values, like a total count, unique counts. This is a minimum, maximum, standard deviation, mean is 570 of the amount. A mean of amount, transactional amount is 570. Imputing the missing values here, I'm imputing the amount by median and the categorical values by mode. Um, so we knew the structure here, and we can see fraud rate is imbalance. There is a class imbalance in this data set. Only 3% are fraud and 97 are genuine. We can By this we can say that it is difficult to perform clustering on this data set, but building predictive models is with accuracy is much more easier. So the purpose here is to detect the anomalies in transaction behavior so that it might be useful for financial institution uh, uh, to follow the trend to prevent the high risk transactions. So business context, as I told you before, and the main problem here is we need to identify which factors, like among the amount, the device or card type or location, which are most likely linked with fraud cases, and can unsupervised techniques like clustering can help detect anomalies. Here, anomalies are the fraud cases, and how well supervised models can perform with higher accuracy, more than 90%. So here we're detecting and treating outliers. So we can see there is an outlier, so many outliers in amount column. This goes around to 16,658. There is a transaction amount, even though the mean is 571 and median lies around 505. The amount goes to 16,658. So this indicates so many outliers in the amount, and this is of genuine, and this is of fraudulent cases. So we need to remove this outlier. This is also the depiction of outliers here. There are so many outliers. So we're treating and we're detecting and treating the outliers using winsorization, the capping technique here. So this is before capping the outliers, and after capping, there are no outliers in the amount column. Transaction amount distribution. This is the amount distribution and their count. So after removing treating the outliers, we have this range of amount and its distribution here. This is a fraud count by transaction type. So what kind of transaction type, whether it is online transfer or point of sale or ATM, has more of fraud cases. Here we can see online and point of sale tend to have more fraud count, 58 and it is 49 compared to transferring an ATM. Fraud count by device type, we can say mobile is more prone to fraud cases compared to desktop and tablets. Card type distribution, here we can see the 49.6% fraud cases are from credit cards. So credit card type have more prone to fraud cases here. Online, uh, yeah, from these three plots we can say online, credit card and mobile phones are more prone, and this they follow the trend for fraud. Transaction amount by fraud label, we've seen before there we had outliers, now there are no outliers since we removed them, and they lie between like the median value 503 and mean value is 570. So this is a fraud over time, monthly wise, how the fraud rate is changing. So this is a geographical distribution of fraud. So since this data set mainly is of India, so there are main labels, fraud labels 0, which are genuine. Here there is no indication of a yellow, which is a fraud. So actually this plot does not give much information to us, but just to depict I have added these. By amount range, so by this amount range we can see here fraudulent cases, the count is 79, 500 to 1000 the amount range. Count of fraud is 79 and 100 to 500 amount the count is 48. Is a fraud rate heat map, device versus card. This does not give much insight, but yeah, we can say credit and desktop. This has a higher value compared to other heat map here. Credit and desktop has a higher value, 0.03 comparatively. So this is a parallel category plot from Plotly. You can see online there are 1485 count, among which mobile, as we saw, have count 2985, credit card which are more prone, and among them fraudulent count we have 147. So most of the fraud cases among 149, 147 are from credit card. So this also says that the fraud label 1, which is fraud, and 0 genuine, this is genuine transaction are spread overall, but the fraud transaction are mainly concentrated in this region, which is the mean, like around 500 to 600, 570, 580, around such region there is a high concentration of fraud. There's a sunburst here. There is online mode of mobile and their count, and one, it is a 31 from mobile and online, 31 mode, and here we can see the count is 15. So mostly through online is the higher count we can see. So by weekday, there's a fraud bar plot. We can see weekends like Sunday have higher fraud risk here. Sunday, Monday. So these days are mainly the transactional days. So this correlation heat map. So amount has the strongest of correlation here. Latitude and longitude have negative correlation, which does not give any much insight to us. We can say latitude and longitude in the data set are of not much use for us. This is a scatter plot of all. We can see the fraud cases distributed. The yellow scatter plots are the fraud transactions. So the violent plots, these are the genuine transaction. They're concentrated of almost little from 0 to 1500, but the fraud label transactions are concentrated mainly in the median region, that is 500 to 600. So that amount is usually a fraud transaction amount. So this is a 3D scatter plot. The yellow points depict the fraud transactions amount around latitude and longitude. This is a fraud trend by transaction type. So the transaction type, we have four among them, and we can see online, most of the here online transaction type have higher tendency to that they are prone to frauds. This is a Sankey diagram of transaction flow. Here is the transaction type, device type, the card type, and whether it is genuine or fraud. You can see the fraud cases here are 28 from the credit card, and among them mobile are 24, and point of sale. So the count it tells the flow of the fraud cases here. Online, desktop, credit, and fraud. So this is the flow we detect for the fraud transactions. So EDA based conclusion we had is it reveals the fraud is strongly related to higher transaction amount, and notably we saw it is online, credit card, and mobile are more prone. So, and is performing hypothesis testing here. Null hypothesis of taken fraud occurrence is independent of card type, and alternate hypothesis fraud occurrence is significantly associated with card type. I've used chi-square test here. By chi-square test, we found the p-value to be greater than 0.05. So Thus, we fail to reject null hypothesis, and we can say there is a significant relationship between the fraud case and card type. Now, unsupervised machine learning. The common setup I have taken, encoding the categorical values and then standardizing them using standard scalar. Shape after cleaning and scaling, we have 4,901 rows and 3 columns. And numeric features are amount, latitude, and longitude, among which latitude and longitude are of no use for us. Then dimensionality reduction, PCA obvious fraud versus genuine, which are like two. I have reduced the dimension to two of them, fraud or genuine. We can see the red dots here are the fraud, which are separated from genuine. The blue dots are transactions here. So it is easy to class to difference to see the difference in them. Next, the TSNE here to visualize the high dimensional data, we use a TSNE, and this also shows the red dots here are the fraud, which are very few among the whole data set. As I told, only 3% of them are fraud. PCA shows linear reduction and TSNE shows nonlinear mapping. PCA shows overall separation while TSNE performs like isolated forms we have here. K-means clustering. Here we can see I've taken K value as number of clusters as 2. Since there is a target variable having 0 and 1 as the value, I've taken 2 of the clusters. Sorry. So this is a centroid we have. The red dots are the centroid, and it has formed 2 clusters in which the precision is 0.97 and recall is 0.81. Since this is a imbalanced class, I don't think clustering would work well because there are very few transactions which are fraud. So elbow method to find the optimal key value here. By plotting the elbow method, there was a sharp decrease until 2 and between 2 and 3. So we took the first occurrence 2 as the number of clusters here. In hierarchical clustering, I've used both agglomerative and divisive. Sorry. So after there's a PCA projection. After dimensionality reduction, I've done the clustering. Here also it gives the same precision and recall and F1 square. Divisive. So estimated number of clusters here in the divisive is also 2. This 2 clusters we have here, this and this. So it is divisive. So estimated number of clusters by dbscan is 2. dbscan checks for the dense clusters. This is a main shift clustering. So this data set is not mainly for clustering but for predictive modeling. So there is no proper insight from the clustering we have here. Then comparison plots of the same of all of these. All the clustering techniques show similar trend in clustering. So inside clustering won't perfectly separate fraud versus genuine, since the fraud data is only 3%, and almost it has the same features that normal patterns follow. So clustering is not a proper method to use for this data set. A priori algorithm we have here, there's a support of 0.13 confidence and left this value. Yeah, so by unsupervised learning, we can say PC and TSNE, they separate the fraud clusters from genuine transaction, and k-means hierarchical clustering and db scan, they found the anomalies as outliers and revealed the fraud prone groups, but means they clustered into two groups, the gray one and the green one. So association rule uncovers strong fraud patterns. So online and credit and mobile, as we saw in the EDA, are more prone to fraud. Supervised machine learning, the common setup, like a training set and testing data set we have. Training, I've taken 3,430 of them, and a test size 1,471 rows. Logistic regression on performing, we get an accuracy of 0.54 and recall of 0.40. So logistic regression has not much higher accuracy, but ROC is about 0.8. Adding them, we get 0.80. So this means uh, logistic regression failed to capture more patterns here. So next we move on to random forest. Here we got an accuracy of 0.97. So it performed better than logistic regression, and we can say by the accuracy that it captured more fraudulent cases and its patterns. So we can say, rather than the regression models, we can use tree-based models for this type of data set. XGBoost on performing, we got an accuracy of 0.95 and recall of 0.04. Since accuracy is higher, XGBoost overall it has given high performance. ROC and AUC is about 0.94 when added. So not only catching the fraud patterns, but also balancing the data we can see in XGBoost. So comparison table we can see. Of course, random forest has higher accuracy, but precision recall, when we look into the um, overall matrices, XGBoost performance is higher comparatively. So model performance comparison here is just about that. From supervised learning, we can see logistic compared to all the three, XGBoost achieved the best precision and recall around 95% like that. And so we can say tree-based models are more suited for the dataset. And finally, to summarize, this is an imbalance classification problem. Logistic regression provides a simple, interpretable baseline but struggles with recall. Random forest improves uh, accuracy and ASU, while XGBoost gives the best trade off overall. So, for a production system, XGBoost would be our candidate model, but we must also tune decision thresholds to balance the false positive and false negatives depending on the business priorities. So that's all about my project. Thank you, ma'am.
Okay, Siddha. So you have done all of this, like from the supervised to unsupervised as well. So unsupervised
Yes, ma'am.
didn't work well, right? that much, the
Yeah,
font
ma'am.
you have chosen. Okay.
Because of
Because
the data set being
non-fraud, yes,
imbalanced, yeah, only 3% of the
right,
date
right.
in the data
So,
set transaction
okay,
were
fine, got it.
fraud.
Okay, great.
Yeah, ma'am.
I understood. Fine. So you can do one thing for this supervised. You got like for the model like the random forest, it worked good. Like the accuracy level is good, but precision recall didn't went well, right?
Yes, ma'am.
So you try and do the hyper tuning over over random forest. Try and do the hyper tuning part, hyperparameter
Okay,
tuning
ma'am.
in the random forest part, and try and check if the precision recall value changes or what exactly, because it is totally on the data set, right? So
Yes,
none
ma'am.
can predict. So you try and use the hyperparameter, like cross validation and hyperparameter on the random forest. And for the unsupervised, we can't see anything because of that data. So if you
Yeah.
try and balance out that data also, the will that work? If you try and balance out the data, like if you are trying and working with the unbalanced data or anything like that, if you are trying to do it?
I can check, ma'am. I can add few more data to it, and
Yes,
I
yes.
can have it check.
Yeah, try and do it. But apart from this, you have followed all of the steps. That good to see. And I'll just want you to like it's like project wise it is okay, but I just want you to improve your presentation skill as well. Okay. Apart from that, everything is
Yeah.
fine. Okay.
Okay, ma'am. Thank you, ma'am.
Okay, Fida. Yeah, Fida. You can just like stop sharing. Next is Priyanshu. Priyanshu, you're there, so you can just present your screen.
Yes, ma'am.
Fida, you can
Ma'am,
just mute yourself.
is my screen visible?
Yeah, your screen is visible.
Hello, all of you. Myself Priyansu, and today I am presenting my project on urban segmentation using PCA and K-mean clustering. Firstly, we will talk about the method I used. So PCA, Principal Component Analysis, it basically dimensionality reduction technique. It conducts many correlated feature into a smaller set of uncorrelated feature called principal component. And then K means clustering. It is a popular unsupervised machine learning algorithm. It groups data into K cluster based on similarity. Then the steps of the K-mean clustering are: choose a number of cluster K and assign the point to the nearest cluster called centroid, and recalculate the centroid until they do not change much. Then elbow method, a technique to find the optimal number of cluster and plot the inertia within cluster variance versus number of cluster. Celoid score, a metric to evaluate how well cluster are separated and ranges from -1 to 1. And +1 points are well separated and correctly clustered. 0 points are the border of cluster, and -1 point may be in the wrong cluster. So firstly, I mounted the drive. Then I checked the file inside my Google Drive. Then I imported the file path. Then in the first cell, I imported all the required Python libraries. Pandas and NumPy are used for handling and data analysis. Uh, Matplotlib and Seaborn are used to visualization. For from Scala library, I imported for pre-processing PCA and for dimensionally reduction. K means for clustering. Celoid score for evaluating clustering performance, and I imported GeoPandas for handling geographical data. Then next I loaded the dataset using pandas. I checked the shape to know the number of rows and column. Display the first 5 rows to preview the data, uh, and use the info function to check column name, data time, and missing value. Then in this step, I handle the missing values by dropping any row that contain null entries. I compared the dataset shape before and after this step to see how many rows were removed. And finally, I displayed the clean data set for verification. Like in original data, we have 65,535 rows and 9 columns. And after dropping the null columns or rows, we have 100 rows and 9 columns. Then outlier can negatively affect clustering. So I remove them using the IQR interquartile range method. I apply this only to numeric column that then align the filter rows within the rest of the dataset. I print the shape before and after removing outlier to confirm the reduction. Before the outlier removal, we have 100 rows and 9 column. And after the outlier removal, we have 98 rows and 9 column. Then I scale the numeric feature using standard scaler, which standardize data. So each feature has mean of 0 and standard deviation of 1. This step is important because clustering and PCA are affected by difference in feature scale. I check the data and scale dataset to confirm it has been transformed properly. Then I use the PCA for dimensionality reduction. I apply PCA to reduce the data set into two principal components. This allows me to simplify the data set while keeping most of the important information. I print the new shape and preview the transform data. As you can see, the exponential variation ratio is 0.54 to 0.45, and we have the two principal component PC1 and PC2. Then key means clustering. In this step, I run k means clustering for different value of k ranging from 0 to 10. Value of I calculate two metrics: WCSS within cluster sum of square to check compactness of the clusters, and Silhouette score to measure how well separated are the cluster are. These value will identify the optimal number of cluster. Then we have 0 to 10 clusters. K means cluster, and we have the WCSS score and the Silhouette score. And we have the best optimal solution is best optimal K mean cluster is number 3. Like we have the Silhouette score of 0.528. Then elbow method. I plot the elbow method and the Silhouette score. The elbow method, so the we're adding more cluster stop giving significant improvement. And in Silhouette score graph, confirm the quality of clustering. Like we have the best cluster, we have the number 3. Then we have the automatic best case suggestion. Like from the above clusters 2 to 10, we will find the best cluster from here. So for this, I prefer the 2 for my clustering, like best case slot score the cluster 3, and the best k for the elbow method is 9. And I use the k 3 and cluster number 3 for the clustering. Then the final clustering, after analysis, I choose 3 as the best number of cluster. I apply k-means clustering with 3 clusters and assign cluster label to each record in the PCA reduced data set. I also print how many data point to fall into the clusters. Like as you can see, the urban zone, one for the mixed like urban and rural areas, we have 37. And for zero, like this is a rural areas for 36. And the fully urban area, we have 23 cities. Then the city's name was here alphabetical order. Then the zone name, name, ward numbers, and telephone total number of household, school count, hospital count, road count, park count, and urban zone. Like school count, hospital count, road zone, road count, and park count are same because it only calculated upon the name of the cities. Then I visualize of cluster and the scatter platform. I where each point is colored based on its cluster. This gives us clear visualization of how the cluster are separated and cluster distribution. And GeoPandas visualization in the data set contain latitude and longitude. I use GeoPandas to create map visualization. So in my data set, I don't have the longitude and latitude coordinate. So it show the no latitude longitude column found. Then I skip the GeoPandas plot. Then finally, I save the data clustered data set into a CSV file. This ensures that the result can be reused later for the reporting, further analysis or sharing. And my conclusion is that I cleaned the data set by handling missing values and outliers, standardize the features, reduce dimension using PCA, applied k-means clustering and determine the best number of cluster, visualize the cluster through a scatter plot, and save the final cluster data set. This complete my project presentation, and thank you, ma'am. Hello.
Yeah, Priyanshu, sorry.
Yes,
Can
ma'am.
you just go up once? In the beginning of the project where you have taken down the details, like plotted the, like taken down the first five rows and first five rows of the data in that section.
Yes, ma'am.
Yeah, yeah. Initially, the shape was around 65,000, right? Then
Yes, ma'am.
after you done the pre-processing, what is the date, like the what is the shape that has it came up with?
I'm 98 rows and 9 column.
That is outliers. Shape before
Oh, shape.
outliers and
Okay, ma'am.
shape okay out after removal of outliers.
Yes,
So
ma'am.
it has from so how come from 65,000 the data it has came up to 98 only?
Ma'am, because I added the two data set for the project.
Okay, you added. Okay,
Yes, ma'am.
okay, okay, got it. So you added two data
Yes, ma'am.
set together, like merged it on, right?
Yes, ma'am.
Okay, and then you performed this outlier removal and all of the pre-processing on that
Yes, ma'am.
merged data, right?
Yes, ma'am. Yes.
Okay, okay. So
So that's
after
why I
final
have
pre,
the mostly null values, na?
I got it, fine. So
Yes, ma'am.
that's why I just asked. So after doing all of the removal, like the pre-processing part, your final data set, what does the number, like number of rows and columns?
Rows are 98 and column are 9.
Okay, 98, comma
Yes, ma'am.
9. I got it, fine. Okay, got it. So everything is fine, but I said it, everything was good as you have done the k-means part, that is fine. So I would suggest try and use the like EDA also because that helps us to understand the relationship between the like after you have done the pre-processing, then try and do the EDA for at least 6, 7 plots. Try and use so that we can just
Yes, ma'am.
get an understanding about what exactly our columns are or the features are and how they are actually related to. Fine.
Yes, ma'am.
So
Yes,
that
ma'am.
is fine. And in the model section,
Ma'am,
how
I
you have gone,
completed the
can you?
project according to the given instruction.
I understand, but you can just put in the EDA, like keep it mandatory to
Yes,
put it
ma'am.
EDA part henceforth. So they have given to do the PCA, right? Like, sorry, they have given you the project to do the K-means, right?
Yes, ma'am.
K-means clustering. So the model type they have given in the project, but apart from that, it is mandatory, right? When you are just going ahead, like loading the data set, doing all of the checking on how your data set actually is, doing the pre-processing, then try and do the EDA, then do the model part. Fine.
Okay, ma'am.
Yeah, just go down, just go down. I just want to see the model section where you have given like gone ahead with the training part, like basically gone ahead with the clustering part. So
Clustering
you
here.
have done PCA,
Then K means
PCA, then
clustering.
K means you have done with
Yes, ma'am.
K equal to
Then
2.
evaluation
Oh,
scores.
okay. So before that, when you have done with the plots like the elbow methods and the sellout score, so lower, down, down, down. Yeah, here you have plotted it down. So try and do this, like
Yes, ma'am.
because you have taken it down, you try and do the uh, like the elbow method and the sellout sport first, because based on that only the
Yes,
value
ma'am.
of k has came out. Then you have performed the k-means. So first elbow method, then if you want to put the sellout sport, do it like that, or you can put the sellout analysis later. But do the like elbow method first, because from there only you get predicting the value of k, right? Then put the algorithm, like the method or the
So,
model, that is k-means algorithm, right? So put it like that, then go for the analysis and the plots. Fine.
okay, ma'am.
Yeah. So just minor, like you need to just alter case all of this. Rest everything is fine.
Yes, ma'am.
So it's fine, and you also need to just improve yourself in part of the presentation purpose, like how you are presenting. Fine.
Okay, ma'am.
Rest things are good. So you can just stop sharing.
Yeah.
So
Thank
next
you, ma'am.
is Aditi. Thank you. Next is Aditi. Aditi, you're there?
Yes, ma'am. I'm ready.
Okay, you can just present your screen.
Yeah, ma'am. Ma'am, is it visible?
Yes, it is visible.
Yes, ma'am. Good evening. My project is on career path clustering. The main goal of this project is to group resume into different career paths based on the skills and keywords they contain. This can help student, HR department or career consultants under career directions better. The second I have mentioned here the theory section. In this I have just given the objectives and what all the things I have been mentioned in my project. It is basically the unsupervised project, so many job seekers and students are unsure which career path matches their skills. The objective of my project is to apply unsupervised machine learning to cluster resume into meaningful group like data science, web development, HR, etc. In the third, I have done the setup and imports. Where I have imported the required libraries and downloaded the data. The fourth, I have loaded the data. Here, I have just downloaded the resume.csv file from the Kaggle, and which I have the data too. Uh, it is just in the Excel file, from where I have just chosen here and the all the categories and the resume. It is we can just see the small type, but as I can show in my Excel file, that is very long, which have 963 kind of categories. So the fifth, I have done exploratory data analysis. Before modeling, I explored the dataset, checked the shape, column, and missing values, extracted frequent keywords, which has been plotted a word cloud showing up top skills like Python, HTML, SQL, and etc. So ma'am, here we can see that data shape and the columns which have category 962 and resume means it's the column categorized, and the missing values, as we can see, it's resume and category are zero, missing values are zero. And the sample records the top 20 most common words which are in the numbers, and it is the word cloud for resume text. And here I have done the pre-processing. I cleaned the text by removing stop words and converting into vectors like TF, IDF. Means here this sample clean text, we can see there are lot of words. The seventh, I have done the feature extraction, which are vectorized shape. Here 962 comma 2000, and the next one is dimensional reduction. Here PCA reduce feature for efficiency is been used. The next one is elbow method to find optimal K. So the output we can see in the graph from the increasing to the decreasing path. And the clustering, I have done three clustering types. The first one is K-mean, and the second one is DB scan, which have the unique clustering from DB scan. MP-INT64, and the hierarchical clustering, which have algorithmic plus dendrogram. So we can see the dendrogram like, ma'am, I have just increase the width because the smaller quantity indexes we can't see, that's why. But if I increase too much, no, so the dendrogram is expanding too much. So that's why currently I have just kept the value like 15 comma 15. And the next one, evaluation. In evaluation I have used two I have done the evaluation into two parts. First one is Salute score, which is 0.035, and the second one is Davis Blounden index, which have 2.89. The 12th one is the visualization. Here in visualization, we can see the scatter plot. Means here each dot represent a resume type. The 18th one is the insight. Here I have the clustering, the four clustering like top skills and the keywords are mentioned here. In conclusion, I just can only say that resume were clustered into career paths successfully, and model can assist HR teams in candidate classification. The project summary table, what all the domain, data type, ML technique, pre-processing required, dimensional reduction, clustering method, evaluation metrics, final output and tools I have been mentioned in detail in this table. Thank you, ma'am. I have done presenting.
Okay, got it. So, can you just go up once? Go
Yes,
up.
ma'am.
Yeah, just go up once. Yeah. In the sections where you have gone ahead with I guess going ahead checking out printing the first five, like maybe the first 5 rows or null values or duplicate values in that section.
Ma'am, I didn't use a small amount of data. I have just uploaded the resume file and everything is done automatically based on my code.
Yeah, that is fine. I'm not saying that. This part actually, yes, this part.
Yes, EDA
Here
part.
you
Huh.
have before EDA where you have gone ahead with taking down the details like how actually is the data. There, try and use different cells. Okay, so since when you are getting you are getting the output at one go. Like what is the exact formation? What is the like when you are printing the data for the first 5 rows and columns, that part also, right?
Okay,
In
ma'am.
that section, try and use different cells. And in the EDA, how many charts you have done? Only that word cloud?
Yes, ma'am.
Okay, that is fine, but try and use one or
And I
two,
have
like at
just
least 5, 6. Yeah,
okay,
tell.
ma'am. I have just with that word cloud, I had just mentioned the top 20 most common words used in the resumes.
That is fine, but try and use some more charts also because that will help us to analyze like the initial section, like how our columns of the features are related to each other. Try it in a way like if you want to don't want to go ahead with much of it and you have more in the model section, try and use at least one in the univariate section. This word cloud is fine. You try and keep it at the end. Try and use a univariate section of analysis in the initial stage because in that stage we are trying and analyzing how our data are. Then only we will be performing na. So first try and use like that, like any of the
Okay, ma'am.
univariate, bivariate, and univariate, multivariate types. Then any of the key one that you actually want to put in. Like here, you want to put in this word cloud because it is related to resume, like top 20 most common words that you want to go ahead with. Yes, you keep it, but try and keep it at the end so that it just draws the attention. Fine.
Okay,
And
ma'am.
next you
Yeah,
go
ma'am. Got
down.
it.
Yeah, try and go down. Yes, feature engineering. Yes, that part is fine. You did k-means and what models you have done. Just let me know once. The
I have just
clustering.
the yeah, k-mean
Mm-hmm.
and clustering. I have used the DB scan and
Mm-hmm.
dendrogram and algorithm.
Okay, got it. Fine. So you have just did the clustering part. So your project was mainly what? What was given to go for the clustering model only?
Yeah, ma'am, it
Aditi.
was came in and PCA also.
Okay. No, no, no. I am just asking, like, in your, like, the whatever be the project given to you, like, what project you have chosen, beside that, the type, is it been given only to go ahead with the clustering part? Is it like that?
No, ma'am.
Okay, fine. Then I'll just try ask you to include like a priori form as well, because here in case of this are actually the clustering based a priori part when you'll be going ahead with, or based on that, or that is basically the association rules. There you might try and get through like which parts of or which keywords or which words are going side by side in case of any of the CVs or resume that you are taking into account, or you can try and use the FP growth algorithm also. Fine. Try and use that because I don't know your
Okay,
data
ma'am.
set. See how it is working actually. Okay?
Yeah, ma'am.
Because
Ma'am,
here
in
only,
our
yeah, tell, please.
means what was mentioned in that PDF was like unsupervised learning, key means, and clustering hierarchy, and PCA, and T-sense, and grid search CV, and hyperparametric tuning. So, what all
Okay,
this
okay.
stuff I was required in my project, I have just
Okay.
mentioned that.
Yeah, I understood. You did it, but try like based on that you did clustering, right? So clustering,
Yes.
like what, like you did the evaluation part, where you did the evaluation part on the module, like for the clustering models, where is the evaluation you have calculated? Can you show?
In this DB scan and dendrogram and k-means.
Yeah, what is the evaluation part you have, like there must be any evaluation, like maybe the sellout score you have taken into account, or what actually you have taken.
Means in DB scan I have used the minimum sample as 5. So the unique clustering from DB scan I got is that int 64.
Okay, but I got it fine, but you have basically gone ahead and taken out the visualization basically, right? You have
Yes,
just
ma'am.
taken into account about the visualization. I got it. So that's fine. Whatever you did, that's fine. But for K-means, try and use the sellout score so that you get an analysis of the K-means how it is performing. And eventually, if possible, try and use any of the like the a priori and see how it is performing. Like what are the cases you are getting in through any of the, based on that, because all of these are clustering based, right? So try
Okay,
and
ma'am.
use the
Yeah.
association rule as well, so that you can get an analysis like if the clustering model are performing better, or it is this data set working good with the association model, because PCA you already did, right?
Okay, ma'am. Yeah.
Okay, fine.
Yes, ma'am. I will do.
Okay, fine,
Yeah.
great. Okay,
Can
Aditi,
I?
you can just stop sharing. Yeah.
Yes, ma'am. Thank you.
Okay. So next is Dikshant. So Dikshant, you're ready?
Yes, ma'am.
Okay, you can just present your screen. Okay, your screen is visible. You can start your presentation.
Hello everyone. Today I will be presenting my machine learning project where I worked on student performance dataset. The main goal was to see if we could group these students from this database into different categories based on their grades, their study habits, or other features. Since we don't have a predefined label in this model or in this dataset like good student or bad student, so this is an unsupervised learning model. This means that the algorithm will figure out itself and group by itself. I have used student performance dataset easily available on Kaggle. The step one was understanding our dataset. I use It our dataset contain details like grades, study time, absence, health, and even some more demographic informations about students. In the first step, I have imported some libraries. I have checked the shape of the dataset and printed 10, the first 10 rows of my dataset, a number of columns, and the names of those columns. We have looked at viewed sample rows, check for the missing values. If our dataset contain any missing values, look at the summary statistics. Now our step two is the data cleaning and pre-processing. The data set has both numerical columns like age, study, and categorical columns like school and gender. Since clustering and dimensionality reduction techniques like PCA need only numerical values, so we are encoding categorical variables using one hot encoding. We are now dropping the redundant features and feature scaling. I scale the data using standard scalars, so all features are on the same scale. After this step, the dataset was ready for clustering. Here we have verified the prepared data. Step three is dimensionality reduction. After encoding, we had lot of columns. Like high dimensional data can be noisy and harder to work with. So I use PCA, which is principal component analysis, to reduce the data into just two main components. The main idea of the PCA here is keeping the most important information here, and reducing the unnecessary noise. So in my case, the first two components explain a decent amount of variance. This also made it easy to visualize cluster later in 2D. Step four will be like choosing the number of clusters. Now I had to decide how many groups should we form. I use two methods here, elbow method and sellout score. This is elbow methods. I plotted the within WCSS. Here we are using elbow method to design the best number of clusters. On the x-axis, we can see number of clusters, and on y-axis, we can see WCSS, which tells how tightly the group the points are. We can see the curve drop sharply from 2 to 3, but after that it flattens out. That means that after the blend, after the pending, or after the elbow, the three cluster is the best choice. Adding more cluster or adding more clusters doesn't really help in a one model. Then cell outage score. I have also checked the cell outage score, which measures how well each point fit into its cluster. The score was highest as 3 k equal to 3. That's 0.402, which again confirms that three clusters separates the students the best. So here we are doing the clustering with three. Step four is visualizing our clusters. I have imported matplotlib DD. Here are a cluster of students scatter plot. This scatter plot shows the students grouped in three clusters mainly using PCA for our visualization. Each dot represents a student, and color represents the different groups. Here, these big black arrows across marks the centroids, the center of each cluster. We can clearly see that three distinct groups are forming here, which means the clustering worked very well. Here is step five, cluster profiling. After forming the clusters, I wanted to understand which makes each group different. Like I created a heat map of average values for each clusters. Cluster 0 had students with moderate study time and decent grades. Cluster 1 has showed the students with slightly higher study time. Cluster 2 shows which had students which had lower grades and higher absence. This heat map gave us a nice summary, a quick summary of the characteristics of each student. Here we are visualizing distribution per cluster. It's box plot for deeper our deeper analysis. Like this box plot shows it final grade G3 and is distributed among the clusters. We can see that the student in cluster 1 generally have higher studies, cluster 0 is in the middle, and cluster 2 has the lowest studies. Here we have cluster centroids to understand the typical students in each group. Now we are here visualizing the clusters with TS and E. Scatter plot. This is another visualization method. It is useful for confirming the clustering results. We can see that three dots, some uh, distinct dots of groups forming of students, which supports the earlier PCA scatter plot. Now we are here is our dendrogram hierarchical clustering. Finally, this is a this is a dendrogram from hierarchical clustering. Each branch shows how students emerge into groups step by step. If we look at the tree, we can clearly see that three block clusters are naturally formed. And so this matches with the result we got from k-means. What's our conclusion? I started with the data performance, student performance data set. I cleaned it, pre-processed it, applied k-means from the number of clusters. The final takeaway or the final conclusion of this project was we can meaningfully separate students into groups in different categories like high performance with good study, or average student with moderate efforts, or lower performers with higher absence. This kind of clustering could help the teachers or anyone to identify which students may need more support or which are already doing well. That's all.
Okay, Dikshant. Yeah, based on your presentation, I would just suggest you to like you did the hierarchical clustering, like the dendrograms basically, right? So I'll just
Yes, ma'am.
hello, can you hear me?
Yes, ma'am, I can.
Yeah. So you have gone ahead and done the hierarchical clustering, right?
Yes, ma'am.
Yeah. So I just want to just divide it into two parts. The agglomerative, do it separately, the agglomerative one, and visualize the dendrogram, how it is forming up, and eventually try and include the divisive one. Right? Can you hear me? Am I audible to
Yes,
you?
ma'am. Yes, okay, ma'am.
Yeah. Try and include that. Rest part, I guess it was fine. And did you perform EDA?
Not really, ma'am.
Yeah, so try and include that as well. If possible, from the next project, try and include that as well, right?
Sure, ma'am.
In the initial sections. Okay.
Okay, ma'am.
Okay, Dikshant. Yeah.
Thank you.
Next is Himanshu. Himanshu, you're there?
Yes, ma'am.
Yeah, you can just present your screen.
Okay, ma'am. So, ma'am, my screen is visual.
Yeah, your screen is visible.
So, good evening, everyone. My project on student performance clustering. So, I presented. The goal was to use machine learning to find natural grouping in the data without any natural grouping in the data without any predefined level. We look at the methodology, the K algorithm, and the Python code used in implement them. The first step is always to load a prepare the data. We started by reading a CSV file into a pandas data frame. Then we select only the numerical features for the clustering analysis, and algorithms like k-means work with numerical distance. This clean this clean numpy array X which contains all student data we will use for the analysis. Next, we scale the data so that features with large range don't dominate analysis. We then use principal component analysis to reduce the data dimensionality, making possible to visualization our high dimensional data in 2D. Here is here Skitlearn make it simple and standard scalar hands-on scaling and PCA transform our skill data into just two components which we can easily plot. Here, go. Find the best number of cluster or we can just guess the iterate through range of potential values for k and calculate the simulated score for each. A higher score indicate better defined clusters. Yes, data, yes. Yeah. This loop like k-means model each k and store its stimulate score b then simplify find the k resulted in maximum score which in this case here which in this case was 6. Apply k-means in visualization results with our option k-means k6. We run the k-means algorithm on last time, the fits predict method assign a cluster level to each student. We then use C1 and Matplotlib to create scatter plots, coloring each point by its cluster level and marking the final centroids with an X. This code clearly visualize separate of 6 student groups and as a alternate I also use hierarchy cluster. This method builds a tree structure for bottom to display linkage function and compute the hierarchy and then dendrogram function a plot it. After this dendrogram is a powerful tool to understand. We have uh, this dendrogram a relationship between cluster and different scale of similarity. Descent of deeper visualization. Finally, to get another specific I use TSNE it technique that excellent and revealing the underlying local structure in data. Unlike PCA, we run TSNE on the original high dimensional scale data. This is again very straightforward, and the resulting plot often so clear and separating between the clustering than PCA. In conclusion, this project is successfully demonstrated end-to-end clustering pipeline by combining skitlearn and skip and matplotlib. We were able to process data, identify an optional number of clustering and visualize the result using the next step would we analyze the characters of these 6 group building meaningful student person. Thank you. That's it, ma'am.
Himanshu, are you like reading from somewhere and presenting it? Is it like that? Because it seemed like that you are reading from somewhere and trying to present it out. It didn't feel the connect that this is this is you are presenting this part, and based on that you are just going ahead and explaining this part. It didn't feel like that.
Okay. Mm, yes, ma'am.
So try and improve the presentation part, and you
Okay.
can just stop your screen sharing. I just need to tell you people something. Suppose, just for those who are just going ahead and doing the clustering method, suppose anyone have done the clustering method. For some people I have seen, so I am just in general telling you, you just check the count for your purpose, what project you did, and in that purpose, just keep a count on. So for K-means, if you are doing K-means, before that, if you are using the elbow method, put the elbow method first, because from there only you are checking the value of K, right? So put the elbow method first, then go ahead for the K-means clustering. I guess some of your mic is on. Can you just mute yourself? Okay. So guys, am I audible to you? Can you people hear me?
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, okay, got it, fine. So as I was saying, for the K-means perspective, so put the elbow method first, then go for the K-means clustering and the evaluation matrix. Try and use the evaluation matrix. You can use the sellout score. You can use the inertia, that is WCSS, that measure the closeness of the point. Okay, like. As I have already told you, like how if the value of inertia is lower, then it is better. Like you're getting the clusters in a more format. Like it measures how close the points are in the cluster centers. Okay. So first allowed score for K means try and use the evaluation matrix, allowed score, inertia, David Bowland index. Any of three you can, if you want, you can three of them you can use. And if any one of you, most of them, I guess you have used K-means along with this hierarchical clustering. So if any one of you are going and doing hierarchical clustering, do the agglomerative clustering. And there also you can do the sellout score, Davis-Bowland index you can use. So if you are doing both, try and include this to evaluation matrix, that is sellout score and Davis-Bowland index, and try and compare between those between them for the k-means and the hierarchical clustering for the agglomerative clustering. Okay,
Okay,
got
Yes,
it,
ma'am.
ma'am.
guys. And
Okay, ma'am.
even for
Yes,
the
ma'am.
DB scan, you can use both of them. And after, in case of any of the clustering methods you are using, if all three you are using, after you are done with the modeling part of all of three, just keep a comparative table. There you are comparing the Silouds code and the Davis-Bowland index for all of this three. Like I am saying, calling for the k-means clustering, then the hierarchical clustering basically for the agglomerative clustering, and the DB scan. Okay,
Okay, ma'am.
try and include that. And if anyone, I have already shown you how the mean shift clustering is using, how we can use it. So there also you can include that also, the mean shift clustering in any of your models if you are choosing any. I'll suggest you, if you want to, try and use the mean shift also, and include the matrices, like evaluation matrix, and check out like which model perform best for the clustering purpose. Fine. And then after, if you are going for the association rule, then the point is totally different. There you will be going for the support, the confidence, and then the lift. This you will be checking. But for this part, basically, for the clustering part in unsupervised, try and use this form. Okay, those who have done, that
Okay,
is
ma'am.
well and good. Who have not done, try to include that. And who have not presented, will present tomorrow. Try to you like add this part at least. If you're not doing anything, that is also fine. But after you are doing, if you are doing this unsupervised modeling, at least three of the model you are doing for unsupervised clustering based, Then for the clustering base, at the end, try and include this evaluation matrix and include a chart where you'll be just taking into account that which model, like in a comparative way, that which model have what be the fill out score and how that is performing. Clear, guys? Understood, everyone?
Yes, ma'am.
Yes, ma'am.
Everyone understood?
Yes, ma'am.
Yes, ma'am.
Okay, okay,
Yes, ma'am.
okay,
Yes,
great.
ma'am.
Uh, okay. So Soumya, today we are out of time. So Soumya, you can present tomorrow. Tomorrow first you will present. Fine, Soumya?
Okay, ma'am.
Okay, got it. So we'll just end our session today here, and whoever has submitted the project, please go ahead and sorry, whoever has presented the project today in the session, please go ahead and submit. Fine. Today you have been given with the Google form. Just go ahead and submit it.
Okay,
Clear,
ma'am.
everyone?
Yes,
Yeah.
ma'am.
Okay.
Yes, ma'am.
Okay. Bye then. Bye,
Bye,
guys.
ma'am. Thank you, ma'am.
Bye bye.
Bye, ma'am.
Thank you. Bye bye.
Thank you, ma'am.
Thank you. Bye.